In this lesson, we're going to determine what is an inverse function and how does it relate to the original function. So let's think about this idea of an inverse. An inverse of a function undoes the function rule. It will undo anything. So if a function rule adds 2, an inverse will subtract 2. If a function rule would multiply by 5, the inverse will divide by 5. And if a function rule cubes a value, an inverse will take the cube root. This means everything is reversed, including the domain and the range of a function and its inverse. Pause and make sure you comprehend that. The domain and the range will flip-flop when we go from a function to its inverse. So let's look at a visual example to understand this. This function turns apples, put it into the function machine, turns it into lemons. But if you put it into the inverse, it goes back to apples. Okay, so let's get some notation. This right here looks like f to the negative first, but that's not what it means. This is read as f inverse of x. It's not an exponent of -1. So as I was just saying to you, the domain and the range are going to flip-flop. Let me zoom in here. So if I have f of x having these ordered pairs of 2, 9, its inverse, f inverse of x, will now have 9, 2 as an ordered pair. 4, 5 becomes 5, 4 in the inverse. So you can see all the x and the y values switch positions. So the domain and range are just flip-flopped. So let's look at what happens when we have ordered pairs, possibly in an XY format. So if I have f and f of x and the ordered pairs are -4, 5, 0, 6, and 4, 7, the inverse, which I write as f inverse of x, will just cause your x and y coordinates to switch. So the domain values on f of x become the range values, and the range become the new domain. So let's look at how this impacts the graph. So if I graph these ordered pairs, I can see it makes a line, and I'm going to treat it as if it's linear for just a second. And now I graph the inverse, f inverse. So let's look at what we actually have here. We have this interesting graphical relationship happening. We have that a function and its inverse are a reflection across the line y equals x, because it's switching your x and your y. So your ordered pairs, if you look, they're jumping across this line here. Okay, so every function and its inverse will reflect across the line y equals x. If you're given an equation and you need to find the inverse, what you want to do is rewrite your equation with x's and y's. Then you're going to switch your x and y. Third, you're going to solve your new equation for y. And then I always rewrite my equation with f inverse notation. All right, so let's do this. Let's find the inverse of the following functions. So I see I have a linear one. So first I'm going to replace my f of x equals with just a y. Next, I'm going to switch my x and my y. So it's going to be -2y plus 1. Okay, and now what I need to do is solve this new equation for y. I'm just isolating it. So I'm going to subtract x from each side, which gives me x minus 1 is equal to -2y. And then I'm going to divide both sides by -2. And when I do that, I actually like to treat this like slope-intercept form. So I make it -1/2 x plus 1/2. And then lastly, since it's solved for y, I just rewrite it in f inverse of x notation. So I get another linear function. And I know it's going to be reflected across the line y equals x. All right, let's find g inverse of x. Notice that my domain is already restricted. It says where x cannot be 5, because if it were, I would have a divide by 0 error. All right, so I'm going to begin by just replacing this with y equals 3 over x minus 5. Now I'm going to flip-flop my x and my y. So I have x equals 3 over y minus 5. And now I'm going to solve for y. So to do that, I'm going to multiply both sides by y minus 5, which gives me y times x when I distribute, minus 5 times x equals 3. I'm going to add 5x to both sides, so I get x equals 5x plus 3. And then I am going to divide by x, so I get y equals 5x plus 3 over x. Let's find h inverse of x by beginning by replacing h of x with y equals the square root of 2x plus 1. Notice the domain is already restricted for us because you can't have a negative radicand of an even root. I'm going to now switch my x and my y. And I'm going to solve for my y. So to do that, I'm going to square both sides. And that gives me x squared equals 2y plus 1. And then I'm going to subtract 1 from both sides. And then I will divide by 2. So when I do that, I could make this actually 1/2 x squared minus 1/2. And I'm going to write this in, rather than f inverse notation, I'm going to do h inverse notation. Lastly, I'm going to find w inverse. First rewriting this with y equals x plus 4 squared. I'm going to switch my x and my y. And now I'm going to solve for y. I'm going to begin by taking the square root of both sides. When I take the square root in equation form, I need to remember to put plus or minus. So this would be y plus 4 is equal to plus or minus root x, and then I'm going to subtract 4 from each side. And I will rewrite this in inverse notation. So w inverse of x is equal to plus or minus root x minus 4. Okay, so I'm going to sketch the graph of w inverse of x, but to help you with that, let's first consider w of x. This is going to be a parabola, and if I think about where the vertex is in vertex form, it would be at -4, 0. And so I'm just going to sketch. This is w of x. So w inverse of x, I know is a reflection across the line y equals x. So it's going to reflect across this. So the ordered pair that sat right here on -4, 0 is now going to be 0, -4. And it's going to be a parabola that opens on its side. So it's going to look like this. So this one down here is w inverse of x. Now, let's follow the directions here. Let's apply the vertical line test to w inverse of x. Well, if I draw a vertical line through this inverse function, it's going to hit twice. So I know that w inverse of x is not a function. So that leads me into the horizontal line test. What's this all about? Well, this is to can be used when you look at just the original function. The horizontal line test works like the vertical line test, but it's used to determine if the inverse is a function. So it states if no horizontal line intersects the graph of a function more than once, then the inverse is a function. So you're looking at w of x, your original. You know it passes the vertical line test. You've been doing that since Algebra 1. But if I draw a horizontal line, well, it hits twice, so this fails the horizontal line test. That means its inverse is not a function. So when I state here, does w of x pass the horizontal line test? No. So that means, like I said, the inverse is not a function. So what we need to do then is we need to restrict the domain of w of x so that the inverse is a function. So what we're going to do is now we're going to say find the inverse of w of x equals x plus 4 squared given that x is greater than or equal to negative 4. So what I'm kind of doing is looking at the right half of the parabola. This is something we frequently do. So the vertex again is still negative 4, 0. So let me zoom in here, right here. And I'm going to restrict it. So 1, 1, 2, 4. So I'm just looking at this side. If we restrict our domain to negative 4 to positive infinity, will w of x be a function? Or excuse me, will w inverse of x be a function? And it says sketch again if we need to. Well, it still passes the vertical line test. So the vertical line test means w of x is, but if I do a horizontal line test, anywhere I draw a horizontal line test, and if I would move this, it's never going to pass through that green curve more than once. So now the inverse is a function. And you knew a discussion of domain and range was coming, right? So we're going to find the domain of the inverse functions below, not above. And we already found these inverses previously in the video. So let's find the domain of our new one. Okay, so the domain of the original was all real numbers because it's linear, and that means the domain of our new one is also going to be all real numbers, so negative infinity to positive infinity because it's linear. Now for g of x, we were given that g of x was 3 over x minus 5, and we were told that x could not be 5. Well, why can't x be 5? Because then we have to divide by 0. So now our new range would not have 5 in it. So, but what would the domain of our new function be? Well, if we look at this, we can see we can't have 0 in our new domain. So it would cause a divide by 0 error. So I'm going to have negative infinity to 0 union 0 to infinity. And just because it's interesting, our range, which couldn't include 5 from before, even though this is not being asked, would be negative infinity to 5 union 5 to infinity. Okay, h inverse of x. Okay, so for h inverse of x, again, domain and range are going to flip. So our new inverse, well, that is a parabola. So I could find the vertex of the parabola. And when I do that, if you think back, I would do negative b over 2a to get the y-coordinate of the vertex. So that would be, well, b is 0. So my x-coordinate of the vertex is going to be 0. And then if I plug 0 into the function, I'm going to get 0, 1/2. So if you just think about what this means, it means that I would have a parabola with a vertex at 0, 1/2, and it's opening downward because my a value is negative. So it would be like this, but I am actually going to undo or erase this side of the vertex because the original domain was x is greater than or equal to negative 1/2. So my domain on my new function left right would be 0 to infinity. right, and then lastly, W inverse of x. What would our domain on this be? Well, we can't have a negative radicand, so it's going to be 0 to infinity.